Hello and welcome to Buildings of Tomorrow, a very special Buildings of Tomorrow. This is the first episode for a new format that we're going to try as part of our show, which we like to call Buzzword Busters. Even for those in the industry who are the most experienced, where it's such an exciting time nowadays with new technologies, new innovations, and new things that we're capable of doing every day. And we'd like to use this format to give you a quick and dirty introduction to some of these buzzwords, some of these new terms and things that you might hear around the industry. Some of them will be old, some of them will be new, but this is like something we'd like to give a go and see what happens. So I'm joined today by Tyson Soutter. He is the Global Business Development Manager for Digitalization at Siemens Smart Infrastructure. Tyson, thank you for joining us.
Thanks, John. Good to virtually see you.
I can absolutely virtually see you as well. I like it. These strange times that we live in. So what I've done, I've taken a very lo-fi approach. We had a chat before this and we sketched out a bunch of different buzzwords, all focused around data. So data from the building, data analytics, all of these different things. So I've taken a lo-fi approach. I've scribbled them down on some pieces of paper here. And for those of you listening just to the audio, don't worry, never fear. I will read them out to you. I won't just show them to the camera, but for those who are watching, they'll get an extra sensory experience with this episode. So the idea is I'll give you these buzzwords, Tyson, and just feel free to give us your thoughts, give us a definition, give us, let's call it the layman's approach to it, so we have a better understanding in the industry about what's happening here. Ready to go?
Ready. Sounds great.
All right, wonderful. So the first one, big shuffle. The first one is interval data.
Great. So when we talk about interval data, we're usually talking about tracking or storing data within a building. There's two types. There's change of value, which means when something changes, and we'll talk about, I'm sure, in the future. And there's interval data, meaning I want to log certain data points or data at a set time frequency. So it could be every 1 second, it could be every 1 minute. The standard time interval is 15 minutes. So logging like a temperature sensor, for example, once every 15 minutes. And the reason we do this and why it's so common within our industry is historically we just didn't have the technology and the storage and the network capacity to be able to log all the data live like you'd expect to see in very high-end modern solutions. So it's very common to say, hey, I want to store data at an interval so I can understand what's happening within the building, but without overloading older technology or older networks.
Okay, so like a time interval to take data samples so that we don't have a flood of information coming through the network.
Yeah, exactly. And that's because the older networks and older systems just couldn't handle it. We're getting to a point now where they definitely can, and that interval is getting lower, and we see different types of storage now.
Beautiful. All righty, thank you. Next one. Oh, this is a good one. This will fit well with what we just talked about. Data lake.
Yes, data lake. It's definitely one of the terms that gets thrown around a lot. It's been used in other industries for a long time, but it's saying that we have all these different systems, different processes, and let's not just talk about buildings, but how do we get all these systems to send all their valuable data, their information, to one location? And that is what we call a data lake. So being able to create streams of all this data into a lake and to be able to have it in one location so we can start doing some really intelligent things with it. Now, if it's unprocessed data, it's commonly referred as a data swamp, meaning that it's difficult to use, it's impossible to manage this, and this is its own problem.
Yeah.
You really want to have, there's another term related to this called data warehouse, which is structured data, and being able to really understand it, have some sort of model behind it. But the most common form we see in any industry is like getting all the data to one location and then let's do something with it from there.
Cool. I like it. We knocked over 3 in 1 there. The data swamp, which I like the analogy, the data lake, and the data warehouse. It's a new one for me as well. Alrighty, next off the pile is change of value. This ties pretty nicely to our first one, I think.
Yeah, so like we spoke about, the interval, which is your time-based storage of data, and then you have your change of value. This means storing the data or capturing the data every time it changes value. Now, an example would be a light switch is very simple. You would not want to check if the lights are on or off every 15 minutes because it doesn't tell you a great deal and you miss it at the action. When does it actually occur? What you want to know is when did they turn on exactly? And there might be a 10 or 12 hour or 15 hour period where it doesn't change again. So having it log every 15 minutes isn't very helpful. So a change of value will log the data when it changes from on to off or off to on. And then every single sequence of change after that, it will log that data as well. So you get the exact time that it's changed its state, on or off, and you get it exactly when it occurs. So you can really see like, okay, when did this happen? Not 15 minutes later, which is very important when you start talking about binary values or like fan starts or chiller starts or these bigger pieces of equipment that are turning on or off. You want to know exactly when they're turning on or off because it's very critical when you start talking about efficiency.
Definitely. I can imagine also when you start to talk about error and things like this, that this is also important to know exactly when stuff happens, right?
Yep. And if you talk about optimizing your start and stop times or looking at when do people enter a building and how does your building react to that, you really want to know when these big things, when are they starting, when are they stopping exactly? Because minutes over the course of a year add up to a huge amount of energy consumption, and that equates into dollar value.
Cool. Perfect. Thank you. All righty. Another good one off the top of the list. There's just the hits keep coming today. Semantic tagging.
Yep. So my favorite topic. This has been used commonly in say like Google search engines or modern technology solutions, but it's basically applying metadata to things so you can understand what they are. So, you know, there's many ways to look at this, but say if you have a temperature sensor, you want to know what it is. It's a sensor. It's measuring temp. It's related to an air system. It has an equipment that it's related to. It might have a location that it's related to. There's a lot of things about this sensor you want to know that you can't get from a name. So semantic tagging allows you to provide metadata or data to data points so you understand what they are, what their relationships are, where are they in a building. And this allows you to do much more advanced root cause analysis, allows you to do scalable graphical design, allows you to do analytics and fault detection. It's very, very powerful. And the reason why this is important, like a great example is if you have a fan and an AHU, a return fan, a return air fan, or a supply air fan, the fan itself is mechanically the same between the two. So if you tag that as a fan, now you know, okay, that's a fan. That fan is the same as every single fan type in a building to a point. So every rule or every graphics that you make, it can just look for that metadata of fan, and it knows, hey, all the rules, all the graphics, all the alarms, analytics that I make for fans is relevant to all of these, no matter what the name is or where it is. So you can really utilize that labor investment. And it becomes very important when you're talking about scale across thousands or tens of thousands or hundreds of thousands of buildings and into the tens and hundreds of millions of data points. You could look at every building in the world that has a fan with a certain manufacturer, a certain model in a certain region, because the tags will be able to filter this for you. So it provides a huge amount of scalability and an availability to data so you can do more interesting things.
Yeah, and I like the word you use there, scalability, because I guess if we jump into one of the topics you've already covered, the data lake, as this lake gets bigger, we don't have an engineer sitting in the corner somewhere tagging or assigning every single data point to a value or a characteristic, because this is not feasible moving forward.
Exactly. Right? And it doesn't stop at just what is a sensor or what is a piece of equipment. It goes all the way into when is it being maintained, who's working on it, who's the customer, what kind of building is it. All of this is data that's so valuable to us And we can, if we understand what it is and understand the relationships to all these data points, we can do some incredible things. But until we have that data structure using semantic tagging, it becomes very difficult. And there's different models out there. Haystack 4 and Brick are the most common, but they're all good and they're all very relevant to each other. And if you have something, it's very easy to work with huge amounts of data.
Now, you mentioned Haystack 4 and Brick. Are they building specific?
Yes, exactly.
Okay.
And yeah, and for example, the search engine companies of the world, they came together and created their own schemas and tagging solutions. And that's what makes search engines so powerful today, because you have these standards built into how these pages are made. So you can actually really easily search through them. So they use that same methodology. So we're taking that approach and applying it into buildings.
But to be that powerful, we need to apply it across every manufacturer, everything.
Exactly.
Good to know. All right. I need to move on. Otherwise, we'll talk about semantic tagging for days and we'll be in trouble. The next one, it's a little bit similar to what we've had before, but maybe you can give us a bit more detail. Change of value data.
Yeah. So like we talked about before, and you can say change of value data is things that we want to see exactly when they occur. So we talked about fans and light switches, but it could be anything from temperature set points. It could be anything from compressor starts, chiller starts, fan starts. It's very much binary points, usually what you use it for, on or off. Now, set points is an example where it's not, but that's something that you want to see when it changes very quickly. Another great example is in, say, vertical transport or lifts or escalators. You want to see exactly when things occur because they have such a dramatic downstream effect of how they relate to each other. So if someone presses the button, you want to be able to see exactly what happens as soon as they press that button. You don't want to wait time. You really want to make sure it's happening straight away. So anything that is either binary is very good to do change of value on, or anything that is very critical, you want change of value. So if you want to do vibration analysis, you want it to be either 1 second intervals or change of value. You really want it to be, tell me exactly what happens as soon as it happens.
Beautiful. I like it. Next off the list. All right, this is another triple banger, let's call it. We have 3 in 1. Reactive, preventative, and predictive maintenance. You'll have to run through us in the most logical order that suits you. Okay,
so reactive maintenance is maintaining things when they break. So something's failed, you go there, you maintain it, you get it back up and running. It's you wait till it breaks and you say, hey, let's fix it. That's it. You need to do that to some point. You can't avoid it. So that's reactive maintenance. So fix it when it breaks.
And that's sort of standard operating procedure for us in most cases in our industry, right?
Yes, exactly. And then you have preventative maintenance. And this is where you have your routine checks maintenance. So I need to do, every country has statutory requirements where you have to do things for health and safety reasons, which is very good. But then there's a lot of companies and corporations, they put further preventative tasks on top of that, meaning I need to maintain all this equipment so I can provide a certain level of quality, a certain level of uptime, and a certain level of energy consumption. So it's about saying every month, every week, every day, every quarter, once a year, I do these checks. I go and check the filters. I go replace fan belts. I do chiller maintenance every year and take oil samples. All these things as part of your preventative maintenance. You schedule it in and you execute it routinely, month on month, week on week, day on day, depending on the nature of the task.
Yeah. So you that schedule that you talked about, you set up this schedule, knowing from history and knowing from experience how often you have to check something to pick up a fault before you get this failure, like you described with the reactive approach.
Yep, exactly.
Beautiful. And the last one, predictive.
Predictive.
There it is.
Of course. And the most exciting, of course. So predictive maintenance, you want to be able to look at how something's running today and in the past and start saying, okay, instead of waiting for it to fail, or instead of doing routine checks, I'm going to monitor a whole site and tell people exactly when to go do the maintenance on this equipment, the most ideal time. No, so not checking it when it's working, like you would do in routine maintenance, not checking when it's failing already, but starting to check it as it starts getting to the signs of failure. Now, this is a term that gets misused a lot. You're not predicting something before it fails. That's not really that possible unless you have huge amounts of data and you can do some best practice guesses. You're predicting as soon as it starts to fail, when do you need to intervene before it becomes a catastrophic failure or before the failure is realized by the people in the space. So if a fan will start to fail slowly, it doesn't happen instantly, unless there's some sort of catastrophic electrical fault. So you can actually see it at 99%, or refrigerant leak's a good example. You can catch at a very high failure rate, so it's barely noticeable. No one would be able to tell, even if you were connected to it doing maintenance. It's very much, hey, we can monitor this and then send people to work on it before it gets to that point of failure, before it becomes a serious problem. And this allows people to schedule maintenance a lot better. It reduces the effort to be able to do maintenance, but it also allows that transparency and scalability to really come into play. And it's only possible if you're looking at the data at very minute levels of time. And so you have to do it frequently, regularly, and you have to use very smart tools to be able to do it effectively.
Beautiful. But you use the data that you collect to recognize changes in the behavior or the operation of different components, so you can find the best time to go out there and check it out to make sure you don't miss a potential failure.
Exactly.
Beautiful. All right. The next one is digital framework or digital blueprint.
Yep. Okay. So we've been talking a lot about operations.
Okay.
This is more into the design and construction area.
Maybe that was my shuffle. Yeah, maybe I accidentally shuffled all the operational stuff.
So the old way you would design a building is you get consultants involved, and they would use a lot of previously worked out things, and say here's what we want to do with a building. The building owner will tell you what they want to achieve, and they're like, okay, these are the products you install. Here's all the different companies we'll use. Here's how much it's going to cost. Mm-hmm. And this is how you build buildings today.
Yep.
The more modern solution and modern approach is saying, okay, what do I want to achieve as a building owner? Not just in construction, but for the life of the building. And you can describe what the outcome is going to be once it goes live, and what happens during the construction piece, and say, okay, to be able to achieve this perfect smart building at the end over here, we need to be able to be really clever with what we do from day one of design. And that's not just, infrastructure, physical, but the digital infrastructure. So what network do we have? What's the connectivity practice? How does things talk to each other within a building? Not what products are being installed, but what are the capabilities of those products? What's the capability of all these different systems that are going into my building? How do they come together into a data lake? And how do they work together? So that's where you need to have a really smart approach and say, okay, I've done the architectural blueprint. I need to also do the digital blueprint. Mm-hmm. What is everything I need, from stream data, like physical hardware connections into everything, to what capabilities do I need about all these things that are being installed to be able to enable this smart building? And that's why we're seeing now with more buildings that are built today, they have these big networks that are part of the building network now. So all these systems are sitting on it, and you can talk between different systems. It's becoming very close to these ideal smart building solutions. And that's because they're designed in a way where they're not thinking about just the architectural blueprint, but also the digital blueprint.
So it's taking a functional approach to planning, but a really holistic, and not just looking at what does it need to do day to day, but how does it communicate, how does it collect information, how does it provide information, probably more importantly, depending on the layer of the component we're talking about, so that those next steps, those future steps into some of the things we spoke about before, the data lake, the collection, is easier to achieve today and in 10 years and 20 years, etc.
Exactly. So you're not buying a product or a solution just for construction. You're buying it for the life of the building, and it's all working together to be able to provide this digital landscape you want to achieve at the end.
Nice one. Alrighty, next, the pile is getting lower, but we're getting through them, which I like. The next one is digital landscape.
Digital language.
Sorry, yeah, digital language. Sorry about that. It's my writing. This is the problem. Yeah, this is what happens when they let me do the writing for myself.
So this goes into this perfect choice, by the way, John. It goes into what we just talked about. But if you're a building owner, if you're a multi-tenant operator, if you have many different properties and facilities, you want to be able to talk between them all. If you have global operations all around the world, if you just have it in one country and you have multiple buildings. In the past, we get caught up with like naming conventions and these things. This can be quite limiting. And what a digital language does, it allows you to scope out what do I need to capture for my digital blueprint or my digital plan to exist at the end of any new build or any existing building. So what a digital language is saying, I need to understand what data do I need on an asset? So do I need to understand how much does it weigh? What's the make? What's the manufacturer? When was it installed? When is it? Who's responsible for maintaining it? This is all facility operations data that you need. Then you need, okay, what live data from our building systems do I need? Do I need starts, stops, sensors? Okay, and then you need, okay, what design and commissioning data do I need? All of these things are being collected when a building is being built, and it's also being updated once it's built and being maintained. If you don't have a digital language to be able to say, by bare minimum requirements, I need all my partners, all my contractors, all my facility managers to provide this list of digital language, then I can't maintain my buildings remotely. Then I can't do what I want to do in terms of a digitalization approach. So it's about creating that list of here's all the data I need, and it might go across 15 different contractors, but I need this no matter what to be able to maintain my building remotely. And you could say it's the start of a digital twin, but it's very much here's the data I need no matter what systems are installed, no matter what contractors or facility managers are there. That is what I need provided to me in some sort of digital form. And if you start with that, then when you do a new build, when you do any sort of retrofit, or even when you're negotiating contracts with contractors, you know the base level of digitalization you can achieve. And now you can really open up a lot of solutions and possibilities. So we work with facility managers and building owners to help create those lists.
So is it a list? Is it a scoping document, or is it more flexible than that and more functional than that?
It could be as simple as an Excel sheet if you wanted it to be. There is tools out there which you can basically capture it during the design and construction piece. There's tools that you can put it into basically anything. You can make it anything that you want. As long as the data is in some sort of digital form, that's where the power comes from it. There's so many tools. I don't want to go into any of them, but of course, you can really say, hey, this is what we want to achieve. How do we achieve it? As long as we can get there, that's the main thing.
And as long as you take that holistic view, like we talked about with the digital landscape, as long as you have full clarity on what would be required during that operation phase, so that you can bring in those expectations at the very start of the whole process.
Exactly. And it sets you up for success. If you can really clearly define what you want to achieve, the framework or the digital blueprint that we talked about, that becomes easier. Then the decision-making process on who you work with becomes easier. And then you can really open yourself up to really modern solutions.
Beautiful. All right, the next one is a big one. This is something we hear every day of the week, no matter where we are or what we do. Digitalization.
Yeah. Of course, it's in my job title. I had to get the one buzzword in there.
Yeah, global's in there too, so I assume you know what you're talking about. Right?
But digitalization just means taking static information and putting it in a digital form. It's or just to putting it in some anything into a digital form. So even say we do auditing of a building. This was done manually. You'd walk around and you'd write it all down, type it all up. Even that is some sort of digitalization. It's not ideal because it's still static, but if you can create some sort of tools where you start bringing all this static information it's in the building somewhere, all this great valuable information is in the building somewhere, and I'm relating it back to buildings, and putting it into a digital form, that's digitalization. An example would be in our industry is when you build a building, you finish the job and sometimes you'll hand all the documentation over printed or CD-ROMs still on brand new buildings, or USB drives. They're closer to digitalization, but they're still very far from it. So taking all these like static PDFs and all this kind of really static information and putting it into some sort of database, to me, that's what we're talking about when we're talking about digitalization. Yeah, so using traditional manual processes and technology to be able to enable them.
Perfect. So a process, it could be a task, a process, almost anything. Moving it somewhere where it's automated, or even not automated, but at least the output from that process is in a digital format that you can then maintain, access, leverage using a digital approach.
Exactly.
Beautiful. All right, the next one. This could be a simple one, but I don't know. Connectivity.
Yeah, it's. I think everyone has different definitions for this, but in our industry, it's about how do we get data. I'm trying not to use the word connect. Get data out of systems. So, if anyone's worked in buildings at all, if you go into a building facility manager's office, historically they would have 15 or 16 systems that they have to at some stage look into. So they all talk on different networks and protocols. So these are all connectivity options. They might talk on BACnet, they might talk on Modbus or LON. These are network terms, but they're all talking to each other. So connectivity is one, how they talk to each other through a network, but then really, how do we bring those systems together? How do we connect into those systems? How do we get data from those systems into other tools? And this can be done through, like I said, BACnet. It could be done through REST API, which is a software connection, or it could be even done through, downloading data through CSV. So there's many options, or MQTT is a more modern approach these days. So it's just ways of getting data out of systems, and what ways do you use to get that data out of systems? That is connectivity.
So the connectivity itself is almost like these streams that you talked about that go into the data lake, but there's a lot of different ways to feed those streams. So the connectivity is not just the streams, but also the approaches and the let's call them the tactics required to feed those streams at some point at their source.
Exactly. Perfect.
What do I need you for? Come on.
I wonder the same thing.
Alrighty, this is a big one. Data analytics.
Yep, and this one, it gets used a lot. So we have I'll bring a couple of terms in here because I think it makes sense. So we have fault detection and we have data analytics. So fault detection is checking on did something go wrong? Has an alarm occurred? Looking at thresholds, like, so if something's a very simple one is if a temperature is too hot or too cold, this is a fault. So if it goes above 23.5, oh, maybe that's too hot. If it goes below 21, maybe that's too cold. So that's a basic fault or alarm. Data analytics is a term used in all industries these days. It's looking at taking a bunch of data, analyzing it and saying, okay, this isn't working as we expected, or this hasn't worked as well as it has in the past. So it could be something like a regression model, which is another term, but we'll go and say, if say this piece of equipment was running at a certain temperature and was making a room a certain temperature when during a certain time of year and during a certain outside air temperature, we know it can do that. So if we keep monitoring it, we can start analyzing and looking at that piece of equipment going forward. So we can say, okay, that it's done that in the past. It can produce this temperature in this space during these outside air temperatures. So we know it can do this. If it doesn't do it in the future or it can't, that's when we can start doing analysis on it. Now, that's not a basic fault detection. That is analyzing large amounts of data to say, hey, this piece of equipment in this scenario has done this much performance. Hey, it's not doing that anymore. So that's a very basic and complicated way of saying taking more data, taking more intelligence, and really doing some algorithms against the data to be able to say it's either it's not performing as well as we expected, or it hasn't performed as well as it has in the past. And you can do anything from prediction to say, oh, we expect the energy to go this high during this day type, or it could be looking all the way in the past and saying, oh, it's done this before, it's not doing that anymore. So you can really use it to do some really intelligent and smart things. And that's when you can start doing prediction of maintenance. So predictive maintenance requires data analytics. It's part of it. You can't do it with just faults.
Thank you. All right, perfect. And the last one on the pile, which I think you almost just talked about to a certain extent, but fault detection diagnostics. Is this the precursor almost to data analytics?
Exactly, and it's very, very important. I think a lot of people will downplay it, but threshold alarms and monitoring equipment with very basic faults it has a huge amount of value by itself. So if you want to look at how something's running and you know what it's supposed to do all the time, you can set high and low thresholds and make sure it's doing that. So an example would be if you had a fan and you turn that fan on and there was no air flow coming from the fan. That you could easily do that with fault detection diagnostics. It's looking at, hey, we've enabled the fan, but we expect air to start occurring downstream of this. It's not. Okay, that's a very simple alarm. It's looking at, are you enabled? Yes. Is there air? No. Fault. By itself, that tells you a lot. If you want to take it a step further, you could do the same thing with lights being enabled and no power being drawn. You could do it through temperature alarms, which is the most common in any building. So all of this tells a story, and it helps. But when you combine it with data analytics and what we talked about, it allows you to take the next step. So the fault detection is the first step into any analysis in a building. When you combine that with data analytics and semantic tagging, which we also talked about, that's when you start being able to understand the problem, not just understand a problem, a fault, a simple fault. You can start looking into the root cause of a problem. You can start doing more engineering steps to be able to say, hey, we know there's a fault, but we also know why that's happening. Not just, hey, this has happened. Not just, oh, it's occurred already, we've missed it. Mm-hmm. But hey, this is why this is happening. We need to fix it. So it's powerful by itself, but when you combine it with the other things we talked about, like data analytics and semantic tagging, that's when you get a very powerful story.
I like it. Tyson, thank you so much. We've covered a huge amount of different buzzword busters. I also had a couple of others hiding in there that makes me think like we're probably going to have to catch up again at some point and bust a few more buzzwords along the line. But thank you so much for joining me. And a quick note to everyone watching or listening, thank you also for joining and listening and supporting our podcast. My name is John Lester. Please feel free to comment, like, or share this episode. Subscribe to all the rest of our episodes. We're way above 50 now, and we're enjoying it and having fun. So we're going to continue to bring more and more in your direction. So thank you so much. Thank you, Tyson, and have a great day.
Bye.